Hello friends, we'll continue examples from exercise 3.1 of R.R. Goldberg methods of real analysis. So we'll take the example if summation of n equal to 1 to infinity converges to a, then show that 1/2 times a1 plus a2 plus 1/2 times a2 plus a3 plus 1/2 times a3 plus a4 dot etc. is convergent. Find sum of second series. Okay. Solution. So given summation of n is convergent to a. Given summation of n equal to 1 to infinity equal to a. So let Sn is equal to a1 plus a2 plus dot up to an for every n. Then by 1 limit n tends to infinity of Sn is equal to summation an equal to a. Now other series is 1/2 a1 plus a2 plus 1/2 a2 plus a3 plus 1/2 a3 plus a4 and so on. For this series is equal to say summation of Bn n equal to 1 to infinity, where Bn is equal to half times an plus an plus 1 for every n. Let Tn is equal to b1 plus b2 plus dot up to bn, which is equal to half times a1 plus a2 plus half times a2 plus a3 plus dot etc. half times an plus 1. Then I can write this as half a1 half times a2 plus half times a2 plus a3 plus dot etc. up to half an is in previous term also plus an plus half times an plus 1. Okay. Then this is nothing but this will become a1 plus a2 plus an plus half times an plus 1 minus half a1, which is precisely Sn plus half an plus 1 minus half a1 for every n. Therefore, limit n tends to infinity of Sn, or Tn is equal to limit n tends to infinity of Sn plus half times an plus 1 minus half a1, which is equal to limit of Sn n tends to infinity plus half times limit n plus 1 minus half a1, which is equal to a plus half times 0 minus half a1. Since summation n is convergent, implies limit of n is equal to limit of n plus 1 is 0, and by 2 and by 2. So which is nothing but a minus half a1 implies summation of bn n equal to 1 to infinity is equal to half a1 plus a2 plus half times a2 plus a3 plus dot dot etc. converges to a minus half a1, as Tn is its sequence of partial sum. Sequence of its partials. Each sequence of its partial sum converging to a minus half a1. So thus, if given series is convergent, then by using that, by inserting the brackets for that series, that doesn't affect on the convergence of series. Next example. Does series summation n equal to 1 to infinity n plus 1 upon n plus 2 converge or diverge? Diverge. Does summation n plus 1 upon 10 raised to 10 n plus 2 converge or diverge? So for series, summation n plus 1 upon n plus 2 n equal to 1 to infinity equal to summation n limit n equal to, if I take limit of n, what will get? Limit n tends to infinity of nth term is n plus 1 upon n plus 2, which is limit n tends to infinity by taking n outside, 1 plus 1 upon n into 1 plus 2 by n. This n get cancelled, we get 1 plus 0 upon 1 plus 0 is equal to 1, not equal to 0, and therefore by necessary condition for convergent series, this series is divergent. By necessary condition for convergent series, summation n equal to summation of n plus 1 upon n plus 2 is divergent. Similarly, for series, summation of n plus 1 upon 10 raised to 10 into n plus 2 is equal to summation an. Limit an is equal to, if I take limit of an equal to limit n tends to infinity of n plus 1 upon 10 raised to 10 n plus 2 equal to 1 upon 10 raised to 10, we'll take it to be outside. Limit n tends to infinity of, again we'll take outside n from numerator denominator. 1 plus 1 upon n upon n into 1 plus 2 by n, which is nothing but, which is equal to 1 upon 10 raised to 10 into 1 plus 0 upon 1 plus 0 is equal to 1 by 10 raised to 10 not equal to 0. And again by necessary condition, by necessary condition, for convergent series, summation n plus 1 upon 10 raised to 10 into n plus 2 is divergent. Okay. So that if a1 plus a2 plus a3 dot dot etc. converges to L, a1 plus a2 plus a3 dot dot etc. converges to L, then a1 plus 0 plus a2 plus 0 plus so on converges to L. Means insertion of 0 doesn't affect on the convergence of convergence of series. Okay. So I can add 0 anywhere or I can remove 0 from given series. Okay. So given summation n equal to 1 to infinity equal to L, let Sn is equal to a1 plus a2 plus dot dot x up to plus an for all n, which is the nth term of this nth partial sum of this series, and therefore its sequence of partial sum must converge to L. Then limit Sn is equal to L by 2 by 1, right? Now for series, a1 plus 0 plus a2 plus 0 plus dot dot etc. Tn is equal to a1 plus 0 plus a2 plus 0 plus dot dot etc. which is equal to plus an, where n is 0 for odd n and it is not 0 for for even n, right? Okay, we'll keep this as it is. Then what is your T2n a1 plus 0 plus a2 plus 0 plus dot dot etc. up to plus an plus 0, which is Sn, and T2n minus 1 is equal to a1 plus 0 plus a2 plus 0 plus dot dot etc. up to plus an, which is again Sn. Are such that limit n tends to infinity of T2n is equal to limit n tends to infinity of T2n minus 1 is equal to limit of Sn is L by 2 by 2. Okay. Thus, Tn is sequence of partial sum of series star satisfying 3. So this is the series for which limit of T2n is equal to limit of T2n minus 1. We know that if Sn is a sequence for which even suffix subsequence and odd suffix subsequence converges to L, then that original sequence Sn must converge to L. By that result, T2n, limit of Tn must converge to L. Therefore, limit n tends to infinity of Tn is equal to L, and therefore a1 plus 0 plus a2 plus 0 plus dot dot etc. converges to L. Converges to L. Next example, if summation of n is convergent and summation of bn is divergent, then show that summation of an plus bn is divergent. Solution: given summation an is convergent, summation bn is divergent. Claim summation of n plus bn is divergent. N plus bn is divergent. On contrary, suppose summation of n plus bn is convergent. On contrary, suppose summation of n plus bn is convergent, then summation n plus bn minus summation n is equal to summation of n plus bn minus n is equal to summation of bn is convergent. This is contradiction to summation an bn is divergent. Therefore, our assumption is wrong. Therefore, our assumption is wrong. And therefore, summation of an plus bn is divergent. So, sum of one convergent and one divergent series is always divergent. Is always divergent. Okay. Next example. Let summation of a and b convergent series, let B convergent series and Ni I equal to 1 to infinity be subsequence of positive integers and Ni I equal to 1 to infinity be subsequence of positive integers let B1 is equal to A1 plus A2 plus A3 plus dot up to AN1, B2 is equal to next terms AN1 plus 1 AN1 plus 2 and so on AN2 dot etc. Then summation of Bk k equal to 1 to infinity is convergent and summation of Bk k equal to 1 to infinity equal to summation of An n equal to 1 to infinity. One to infinity. What is the meaning of this example? Suppose I have series A1 plus A2 plus A3 plus A4 plus dot etc. and Ni is equal to say L. Ni is equal to say 2, 3, okay. Subsequence of positive integers. Subsequence of positive integers. Okay. So I am taking 2, 3, then 3, okay, 4, 2, 1, 5 and so on. Then what I am taking, then what is summation Bk here? Bk, A1 plus A2, I am taking first two terms, what is 8, N2 is 3, N2 is 3. So what is meaning of that? A3 plus A4 plus A5, A6 plus A7 plus A8 plus next 4 terms A9 plus A10 plus A11 plus A12 and so on. This is your summation Bk. So if the given series is convergent, then if I insert bracket for terms of the given series, and then by inserting brackets, if I take their additions and if I form new series, that new series is also convergent and it converges to sum of the original series. Sum of original series means insertion of bracket doesn't affect on the sum of convergent series. But if given series is divergent, then insertion of brackets may affect. Insertion of bracket may affect. Okay. So this is exercise. Then should add. Okay. Example of divergent series. Summation ak or an such that a1 plus a2 plus a3 plus a4 plus dot dot etc. is convergent. Okay. So consider series summation of minus 1 raised to n equal to 1 to infinity, which is equal to minus 1 plus 1 minus 1 plus 1, okay, and so on. Each series such that limit n tends to infinity of n is equal to limit of minus 1 raised to n doesn't exist. Therefore, summation of minus 1 raised to n is divergent series such that if I take such that minus 1 plus 1, if I give bracket for two terms, plus minus 1 plus 1 dot dot etc. is equal to 0 plus 0 converges to 0. Okay. So thus insertion of bracket doesn't affect on the sum of convergent series, but if the given series is divergent, then insertion of bracket affects on the divergence of that series also. So with this discussion, we'll stop our lecture here. Thanks for listening lecture carefully. Bye bye.